This puzzle is called Hot Demo by Full Deck and Missing a Few Cards. I got it from the Sudoku Testing Submissions channel of the CTC Discord. Let's take a look at the rules and hop on in. The link to the puzzle will be down in the description if you want to try it yourself. So regular Sudoku rules, great. Thermometers. I guess I've been doing a lot of thermometer puzzles recently. I feel like I've been explaining this at the beginning of every video. But digits increase as they get farther away from the bulb on these lines. So if this is a 4, this has to be less than a 4, this has to be greater than a 4. So something like that would be the options. Let's see, white dots are consecutive Kropke dots. That's Kropke is just the just the word for it. Just consecutive dots. So if this is a 5, this has to be a 6 or a 4. Also delete that. And also the black dots are ratio dots. So it has to have a 1 to 2 ratio. So if this is a 6, let's say, then this, well, 1 second. If this is a 4, this would have to be a 2 or an 8. If this was a 6, this would have to be a 3. And that sort of thing. Yeah, it's pretty simple rules. Also, I'll say that in the description, they said that it was about 2.5 out of 5 difficulty, maybe? Question mark, question mark, question mark is a quote from the post. So let's see how this goes. Yeah, I think that's everything. And the link is in the description. I think I said that though. Let's start by filling in this line. I don't know how other people fill in the lines, but that's how I do it. I just write in the minimums, and then I just when I get to the last cell, I fill it up to the maximums, and then go backwards. Rather than counting the cells, I can never. Yeah, it's just I think I find that the easiest way. So this black dot can't have a 1 on it. If this had a 1 on it, then this would. Oh, why does this keep going on? Pencil marks off. I feel like it does that if it changes that every day. Um, if there was a 1 on this, then this would have a 2, and then both of these would have to be 3, and the puzzle would be broken. So we can't have a 1. It could be 2, 4, it could be 3, 6, and it could be 4, 8. So that's actually a lot of options. We only have that one black dot. That's interesting. Let's see. This is a little bit complicated. Oh, I just noticed that's why they had just the one black dot. It's because all the other dots are symmetrical. And if they, I think that if this was a white dot, it would be 100% symmetrical, which would mean that the puzzle would have multiple solutions. Because you could just, I don't know, I'm trying to hold my hand up, but you could just kind of rotate the puzzle, 180 degrees, and have this be down here, and it would work just as well. Actually, no, that's not true. This thermometer is different as well. So I guess that's not true. They just did that for, so it actually solves, I guess. Let's see. Anyway, here, let's say this was a 1, 2, 3, 4, 5. Whoops. This is not quite the case. I don't think, because if this was a 5, we could do 6, 7, but then this side would be broken. So we couldn't actually do 5 here. And similarly, 4, even if we did 5, 6, whoops, we could do 5, 6, and then we could do, actually this is the soonest that a 7 could be. So this can't even be, whoops, this can't even be a 4. So we haven't, oh, now we have a 1, 2, 3 triple. So this can't be, have a 2, or be 3, 6. So this is 4, 8. I'm, like, right on the edge of a sneeze, but I've been that way for, like, the last 4 minutes, as I've been trying to talk, and, like, I keep on almost interrupting myself to say, oh, sorry, I have to sneeze, and then I just don't have to. So if this was 5, this would be 4, 3, 2, 1. Then this would have to be 4. I guess it wouldn't have to be 4 or 5. Okay, so here's the thing. This, actually, neither of these can be 5. If this was a 5, it forces the minimums down here. But once you get that far, this cell becomes unfillable. So neither of these can be 5. Um, if this was a 3, let me just look at this. If this is a 3, we could have 4, 5 on one side, and we could have 6, 7 on the other side. Does that cause any problems? I don't think so. Okay, so this is up. Yeah, I'm getting a lot of options here. But if this was an no, if this was an 8, the puzzle breaks, and that's actually going to be helpful. If this is an 8, the puzzle breaks because it forces this to be a 9, but then the consecutive dot also forces there to be an 8, and of course that's 2 8s in the row. So that can't be an 8, which is going to come downwards. And the same thing happens here. If this is an 8, this must be a 9 because it has to increase along the thermo, and then the consecutive dot doubles up 8s in the row. So now this can't be a 3 because we only have 4 digits that are greater than 3 available in the column on the thermo, so this can't be a 3 any longer. Let's see. I think this if this is a 5, I think the puzzle breaks. This is a 5, this is a 6. This has to be less than 6, but can't be a 5, so it must be 4. And then this becomes 3, and then we break this again. Just like we did earlier, except we had to do like an extra step for it. So this can't be a 5, so it's just a high digit. Now imagine the same thing happens down here. If this is a 5, whoops, no. If this is a 5, this is a 6, this has to be 4, then this has to be 3, and then this breaks. Yep. It is symmetrical, like 90% symmetrical, but I don't want to... Yeah, I want to double check the logic, because I feel like I'm going to, not do that once, and then the puzzle will break, because it was one of the not symmetrical instances. Okay, right here, these must be consecutive. It can't be 1 through 4, because those are already used. So it could be 5, 6, or 7. And the last digit in the row is a 9, yeah, so that it's 5, 6, or 7, so it must have a 6. One helpful thing, I don't know if it'll pop up in this puzzle or not, every consecutive dot must have one odd and one even digit surrounding it. So, yeah, so this must have a 6, obviously, that's the only option, but that's the only, like, that's the middle digit of the row, but that's just something to remember as well, that there just must be an even. So if we, I guess there's no white dots that could be like this, but if, we determine that one white dot had, only evens on one side, then we would know the other side would have to have an odd, even if the even digits were, all spaced out or something. Okay, so this is, I don't think it's worth filling that in, but there are, I guess this is different. This is one of the symmetrical instances. This is a 5, 6, 7. But we, obviously, it's not quite a triple because there's only 2 cells here. So I don't think it's quite helpful enough. So this is 5, 7, 9 because we have to have the 6 on the dot. Let's see. If this is 6, this is a 5, 7 pair, then this would be 4 or 8. I don't think that's a problem. This is a 7, 6, 5, 4. So this would have to be a 6. I guess that's one thing. So if, I will type this out, although I don't know how helpful it will be. This can't be a 4. If this was a 4, that would mean this is a 5, and then this digit has to be less than a 5, but I've already used the 4 in the box. So this can't be a 4. And I'm guessing the same thing is going to happen up here. If this is a 4, this must be a 5, which then must have a 4 next to it. So this can't be a 4. Okay. Okay, so this is interesting. I don't know how exactly this will help, but it's definitely something to note. One of these two green cells will be a 3. Those are the only spots for 3 in the row. So one of them will be 3, which will force maximums all the way up. So one of these will be 9. But obviously, like, yeah, all the way up it'll be maximums. I don't know what to do with that information yet, but I think that is good to know. Yeah, the only two cells that I see, or the only two sets of cells, are the horizontal ones and these vertical ones that really affect each other. Because like one of these is a 9, so none of these can be a 9. Which will be helpful, but yeah. If this is 6, this would be 5. No, this is 6, it can't be, or it could be 5. It would be 4 or 5, this would be 3 or 4. And this would be a triple. So one of these is a 5. No, one of these is a 7. One of these is a 7. One of these is an 8. Oh, wait, if this is an 8, that breaks the puzzle. Okay, if this is an 8, this is a non-symmetrical thing going on. So if this is an 8, the only thing that can connect to is a 7, which then is going to force maximums up here. So far this is fine until we look down to this 4-8 pair, and it can no longer be filled. So this can't be 8. Now we almost have a triple going this way, same as we almost have a triple going this way. If this is an 8, I don't think that causes any of the same problems. Well, obviously it's not a 4-8 pair here, but I don't think having two 8s looking up at this line is a problem at all. So this must have a 6. Okay, that's important. So this must have a 6. So this can't be a 6. And that's actually hugely important. Okay. So that we just figured out which one is going to be the maximums. So this is 6 or 8. This can't be a 7 any longer. Whoops. Can't be a 7. The thing that I saw that I was excited about was that this couldn't be a 6. But then I realized that, wait a minute, it rules out an option there too. This can't be a 6. I guess for multiple reasons, because 6 would have had to connect to 7, but also there's a 6 in the column. Oh, this can't be a 9 any longer, of course, so this can't be an 8, so this can't be a 7. So if this was a 7, the puzzle breaks. In the same way that 8 broke it before. If this is a 6, sorry, if this is a 7, this must be a 6, which then forces a 7. No, it doesn't. No, it doesn't, because that broke because of the 8s down here. Never mind. Yeah, I was wrong about that, but if this is a 6, the puzzle breaks. If this is a 6, then must be a 7, and then this cell is unfillable. So this can't be a 6, so this can't be a 5. Oh, this can't... Oh, I totally need... These can't be 5s. I don't know if that really matters. This can't be a 4. But what's big is that this cannot be a 4 any longer. I say big, it's not that big of a deal. This can't be a 4. If this was a 4, this would be a 3. And then this cell would be unfillable, so this is not a 4. And we, we have another one of these 5, 6, 7s looking at each other. These 5, 6, 7s just need a third person to pop up, and then they could have a nice little triple somewhere. Let's see. If this is... If I could rule 6 out of this cell, then this could no longer be a 2. That's definitely something interesting. These thermometers in the corners are pretty short. I don't think it'll matter. This cell is restricted to 1, 2, I think, because it can't be 7, 8, or 9 because it's just not far enough along the thermometer for that. But I don't think 1 or 2 really matters because this can be a lot of things. Now this cell actually is restricted a bit. It's at most a 5 and it can't be a 1, of course. So this is at most a 4. Does that help? I'm not sure. Let's see, if this is a 2, this has to be a 6, this has to be a 7. So this is a 6, this is a 5, this is a 6. Oh wait, if this is a 2, this is a 6, this is a 7. So then this is a 6, but that forces minimums all the way down, and that would be a 1? Yeah, that's fine. I was thinking that maybe putting the 2 here could end up forcing a 2 here, which obviously would be a problem, but it doesn't, at least, you know, that quick glance does not seem to be the problem, or the place to look. If this is a 2, this must be a 6. Then this is 3, 4, 5 triple. Okay, well, here's one thing. Where can 8 go in column 5? It can't go here because of this 8. So it must be up here. Let's see. Four, three, two, one. If this is a 3, this is 4, 5. If this is a 2, this is a 1, 2, 3, 4. I don't think that really matters. But if this is a 1, obviously this is going to be forced to be maximums all the way up. So if I could somehow force this to be a minimum while conflicting with this being maximums, that would be helpful, but I don't see how to do that. Oh, I don't know if you could hear that, but my neck just, had a major pop, and I have a crappy microphone, so you might have heard that. I'm just noticing I have close to a triple here. This 8, if I could get rid of the 8, then I would just have the 4, but then I would have a pair. but it's close to something going on there. This digit must be a 1, 2, 3, or 4, I guess. So this digit can't be a 4. No, it could be a 4. It'd be 4, 3, 2, and then this would be a 1. Never mind. Trying to. Hmm. Apologies if you can hear my chair squeaking. I say this almost every video, but I have a very squeaky chair. And I try to hold still, but the microphone kind of just picks up everything, so I apologize. If this is a 3, this is a 2, this is a 1, this is a 2. So if this is a 3, this is a 2, this is a 6, 7. This is a 3, this is a 2. This is a 6, 7, 6. Which goes down to 1, which is fine. Let me just double check the rules, make sure I didn't forget a constraint. The thermometers, yes. White dots, yes. Black dots, yes. Not all dots are given, yes. Okay, so I'm not missing a constraint. That is... Oh! I'm missing the obvious, though. That literally probably took me 5 minutes to notice. So this can't be an 8, so this can't be a 9 any longer. I don't know if that's actually helpful. I feel bad about missing it, but if it doesn't actually do anything, maybe I don't have to feel too bad. There's an 8 along here somewhere. What can this digit be? 1, 2, or 9? That's almost a triple here. Maybe I should look at these digits again, make sure I'm not missing another obvious thing. I guess 8 must be along here, but that doesn't mean that the 8 is necessarily in there. 8 is along here. So if this is 8, this must be 7, because 9 would have to go with 8 as well. So if this is 8, this is 7, 6, 7, 6, 4, 3, 2, 1. And then this would be a 5, 6 pair. Oh, that breaks the puzzle. That's a long chain, though. Okay, let's just mark this so we can see exactly where we started the chain. If this is 8, 8 is removed from both of those. 9 can no longer be here because it would have to connect to an 8. So this must be 7. This must be 6. This must now be 4, 3, 2, 1, which then forces this to be 2, and forces maximums all the way up. Now this must connect to a 6, but can't be a 7, so it must be another 5. So that breaks. That means 8 is not right there, so 8 is on this line. Is there a shorter way that I could see that? If this is 5, this is 6, this is 7. So if this is 2, I don't see a shorter way to prove that. Because it really is that the 8 over here is doing a decent amount of work. It isn't like I jumped in, or if I found like something that happens to force breaking logic. I think it's the 8 that ends up forcing and breaking the puzzle. I think so. So anyway, if there's an 8 in here, that means that 6 can't be on there, so that's good. Let me just look at that some more, because if there is something more simple, then it could mean something like, I don't know, this couldn't be a 4 or something like that. Obviously that's not the case, but something simple as opposed to like this longer chain that proves or disproves the same thing, but isn't nearly as helpful. If this is 4. If this is 4, this must be 2. Because this is 3, 2, 1. I don't know. Yeah, I'm not sure. I think that's just the logic there. So one of these is an 8. Also, I don't even really see how that helps. But I just happened to see that that would break the puzzle there. This is a 4. This is 3, 2, 1. This is an 8, and this is a 4. What does this being a 7 break the puzzle then? No, it was the 6 here that forced this down to be a 4, and then forced minimums all the way down. Because if this is a 7, this is a 5, 6 pair, which forces this to be minimums, which then forces this to be a 2. Oh, that does break the puzzle. Okay, that's a little bit helpful too. So if this is a 7, this must be 5, 6, which means this must be 4, 3, 2, 1, and then puts a 2 over here. And we've said earlier that if this is a 2, this must be a 6. But now how do we fill this digit? This digit must be greater than 6 and less than 7, and that's not possible. So this can't be a 7. Can we do... This is 8, this is 4. Now this, I keep wanting this cell to see the 3, 4 up here. Every time I've looked at this, I'm like, okay, well this is putting a 4 there. That will definitely affect this thermometer. And then it just never does, but I keep looking back like it's just suddenly going to start. Even though that obviously makes 0 sense. Let's look. If one of these is a 9, which does maybe seem likely, I don't know. Then there will be a 9 down here. That's not a problem. If this is a 5, if this is a 2, these are both 7s. So this is 2, 3, 4, 5, 6. Can't be 5 again, so this is 7, this is 7. This is 8. So if this is 2, these are both 7s. I mean, one of these must be a 7, but that's not that big of a deal. Huh. Okay. This is a... If this is a 2, this must be a 6. One of these is a 5, one of these is a 4, one of these is a 3. If this is a 2, this is a 6, 7. And this is an 8, 9 pair. So, yeah, if this is a 6, this is 7, 8, 9, right, like this. So then this would have to be 6, 7 down here. Maybe that's the question. Where can 6 go in this box? One of these is a 6. Okay, that's not very helpful. Okay, so if this is a 6, this is 7, 8, 9. Oh, I guess the 8, 9 could be switched around, but that's not hugely important. If this is 6, this is 7. Yeah, that doesn't matter. Which puts 6, 7 down here. If this is a 7, this is a 6, 5, 6. This is 6, 7. That doesn't, yeah. That doesn't break the puzzle either. One of these three is a 6. Hmm. If this is 7, this is 8, and this is 9. Or I guess it could be switched around. Yeah, this is 7, this is an A9 pair. This is 5, that's all true as well, but that still doesn't affect anything. Hmm. If we put a 7 here, that's gonna force the 6, 7. What if this is a 5? Could this be a 5? If this is a 5, this is a 6, 7, 8. Sorry, yeah, if this is a 5, this is 6, 7, 8. But this is also minimized. 6, 7, which forces this to be 6 or 4, which forces this to be a 1. Okay, so that breaks it. But it's not very helpful. This is a 5, this is a 6. Which forces this to be a 7, which puts us, which means this must be 4 or 6 here. Which means this can't be a 6, which means this can't be a 2, which means this must be a 1. But this 5 also forces this to be a 1. So, in other words, that can't be a 5. Which is one of the most useless chains that I've come up with ever. Let's see. I definitely do kind of feel like there's something obvious that I'm just missing, kind of like the 6-8 down here that we're just sitting here for a year that I never noticed. Well, okay, this is something. This is a 1, 2, 3, 4, 5, because this can't be 6, 7, 8, or 9. That forces, let's not do blue, let's do orange. That forces a quintuple here of 1, 2, 3, 4, 5. This is 6, 7, 8, 9. I don't know how that helps, but oh, that does help a little bit. This can't be a 9 or an 8 because I've said that there's an 8 up here, and also you can't have a 9 partially along the line. So this is 7, 8, or 9. Again, it can't be the 8. Oh, there's literally an 8 looking at it, so that's a 7 or a 9, which is a triple here. Oh my gosh. I've made progress. This is a 6. This can't be a 6. Which puts a 6 up here. Yeah, unfortunately, the logic I was looking at, like, the 6 here puts a 6 here, but it's not backwards compatible, I guess. Darn, I really hoped that that would be a lot more powerful. Yeah, when I saw that triple there, I was like, oh yeah, that's definitely the step, and it just doesn't matter. Okay, so this can't be a 5 any longer. This can't be a 4 because these digits are 1, 2, 3, 4, or 5. And of course, this can't be a 1 or a 2. This actually can't be a 5 either. So one of those is a 5. That's, oh, excuse me, that's almost really helpful. Oh, this can't be a 4 any longer, because 4 would put a 3 here, and that would break that. If this was 4, this would be 3, and this cell would not be fillable. Let's see. So now we have a 6, 7 pair. how does that help? 7 can't be in any of these cells. Not incredibly helpful. If this is a 7, this is a 6, this is a 7. I don't know how that helps. If this is a 2, this is a 6, 7, which forces this to all be minimums, because this has to be a 6, 5, yeah. So then this digit, okay, what digit, what is, if this is like a 4, does that do anything? Hmm. So if this is a 5, this is a 5. If this is a 1, 2, 3, or 4, I don't see immediately how that matters, but I feel like this quintuple is important, so I'm trying to look at stuff, you know, around it and working my way out, but I'm not seeing anything. 1, 2, 7, 8, 9, 1, 2, 7, 8, 9. So if this is 3, this is 2, 1, 4, 5. You know, I've been saying for a while, I hope I didn't break the puzzle, but I've been saying for a while that 6 here forces 2 here, but I don't think that's the case. 2 here definitely forces the 6, but not backwards, necessarily, I don't think. Yeah, I'm gonna just cross my fingers and hope I didn't break any logic there. So where can 1 and 2 go in this row? We have 3 cells for that. It's almost level. Can I rule out 1 and 2 from one of these cells? If this was 1, 2, if they were both in here, then this would be a 9. And this would be a 7. This would be an 8, 9 pair. I don't see why that would break anything. Maybe I don't see how this would help. Yeah, this can be pretty much anything. Hmm. Is there a chain with all these digits? I'm just realizing that there's a lot of interaction here. If this is a 9, this is a 7, 6, 5, 4, 3, 2, 1. This is a 9. So what did I say? If this is a 9, 7, 6, 5. So this is a 9, this is a 1. So if this is an 8, this is a 1. which makes this, if this is a 9, this is a 2. And if this is an 8, I don't think it does much. It just makes this a 4. And this is an 8. What about 6? I guess both. Oh, that's what I. Now I'm kicking myself. 6, 7. 6, 7 pair. I even said this. Rules 6 and 7 out of there, so 6 and 7 are both over here. This must be a 5. This can't be a 5 any longer. This can't be a 4. So if I made this a 3, that would break these cells. If this was a 3, this would have to be a 2. This would be a 1. Now this cell is unfillable. So this is not a 3. And also, if this is a 4, we now have... This has to be... This can't be a 5 then. So now we have 5 cells that are 1 through 4. So that's not going to work either. So this must be a 6, 7... I'm worried that I messed up the logic there. I'm hoping it doesn't break the puzzle, obviously, but also I'm just hoping that I didn't skip some logic, get something for free. Because that always kind of feels bad when you finish a puzzle thinking you did great, and then it's maybe not as great. Okay, okay, I'm gonna get rid of these 6, 7 because that's just so much writing on the puzzle right there. Oh, this is a 6, of course, because there's a 7 right there. That's how a pair works. What's left is 1, 7, 8. And this is the 1, because there's a 7, 8 right there. So this is 2, 3, 4, 1. And this is a 9. 1, 2, whoopsies. 1, 2, 3 are left in the row. This can't be a 1. One of these is a 1. This is a 3 or a 4. These can't be 3s. What's left in here is 2, 3, 4, 5. Can't be 2. Just one of them is a 5, yeah. Oh, this actually can't be a 5. So that's a 5. I'm surprised that this hasn't come into play yet. Let's see. This is 1, 2, 7, 8. Oh, I was kind of thinking that that would help more, but this is just not 2. One of these is a 2. That maybe helps a little bit. I don't know. One of these is a 4, and it's looking upwards. So one of these is a 4, and this one can't be a 4 because of the 4 there. So yeah, we have this 4 blocking there, this 4 blocking there, this one blocking there, and then the 4's here. Yep. Do I have any? Oh yeah, I have a couple 4's remaining. We need a 4. Let's just highlight the 4's. That's probably the best way to do it. One of these is a 4 because we have this looking in, then this looking in. But we also have just, unfortunately, a lot of options there. And then that. Okay. Is it almost time to look at this cell? This cell still has so many options. This could be 6, 7, 8, or 9. Yeah, I don't know how helpful that is. Huh. What about this cell? This cell has less options. It can't be 3. Which I'll mark the 3, but I'll explain why it can't be a 3 in a second. It could be 3, 7, or 8. If this was a 3, then this would have to be a 2, this would have to be a 1. And then we had marked these as being the 2's, but this can't be a 2 any longer. And in fact, there's nowhere in the column for a 2. So this can't be a 3, so that's 7 or 8. So this can't be 6 or 7. We have a 7, 8 pair. So now we have a 1, 2 pair. Oh, actually we have a 7, 8 pair there now. So this must be a 9, which makes this 6, 7, 8, 8. This is 3, it's just 3, 5. And this must be a This must be the 3, this must be the 5. And this is resolved by this 8 over here. This can't be an 8 because of that 8. One of these is an 8. This black Kropke dot is actually starting to annoy me that it's still not resolved. I don't know why it's annoying me so much, but it is annoying me. This was a 5, 6, 7 triple, or just the last remaining place in the row for a 9. This can't be a 2, this can't be a 1. Huh, okay. This is 1, 2, 9, which actually puts a 1 here, right? 1, 2, 9 remaining in the row, 2, 9, yep, okay. This is a 7 or a 9, so that must be a 7. This is the 9. Whoops, whoops. This is a 3, 2. Not resolved. Okay. This is a 5, 6. Oh, there's a 9. I literally put that 9 in there. Okay, so this is a little bit more resolved. This is 4, 8. Actually, that can't be an 8. 4, 8, 3, which puts the 3 here. 4, 8, 4. Coming down home stretch, hopefully. Oh, we have a 2, 3 pair here that I didn't see. I did just fill that in, so I don't feel too bad about that. There's a 6 here that looks at that, so this must be a 7. What's left in this box, or in this column, is 1, 2, 9. Not resolved, okay. This can't be a 2, I guess. Let's look at this column, must be 8, 9. This 8, this is 9, so that makes this resolved. Oh, and there's a 5 right here. Whoops. This must be a 1, this must be a 7, and the last 2 digits are 2 down here. Whoops, and then I typed the wrong digit for the very end. That was a lot of fun. I was stuck for a while, obviously at 2 different points. I don't know if this was the intended way to make progress, the quintuple. That was tricky. I didn't, yeah, maybe I should have seen it earlier, but yeah, that was tricky. And then the 6, 7 pair, I definitely should have seen right away. I literally said it was a 6, 7 pair, but didn't think about it enough. That was a fun puzzle. As always, these two, I believe it's 2 people, are great setters. Yeah, so thank you Full Deck and missing a few cards for the puzzle, and thank you guys for watching. Oh, I didn't say the difficulty. Yeah, probably like 2.5, maybe 3, but I also kind of feel like I made the puzzle a little bit harder on myself than it needed to be. But maybe not. I don't know. It's probably like 2.5 to 3, I think.